This hot dog cooker version uses a current sensor to cook based on total applied energy. We're using a section of a non-contact current sensor demo board. The sensor also provides overcurrent detection for improved safety. As we described in previous videos, rectified AC powers the hot dog. A silicon carbide FET controls the energy to the load. Cooking is controlled by an Arduino. The Arduino Shield has an isolator to separate the Arduino from the FET high voltage, and one of our DC to DC converters powers the isolator and provides a gate supply. So let's energize a hot dog. This is where we added the current sensor. The sensor works by measuring the magnetic field induced in a circuit board trace. The nominal sensitivity is listed in the eval board manual. You can get the exact sensitivity experimentally or use our free web app for different board configurations. Of course, you could use the Biot-Savart law, but we did the math, so you don't have to. It's done. 7 kilojoules. Just like it says on the package. Here's the Arduino program. There are constants for the current limit, target power, cooking profile, and sensor sensitivity. The setup routine includes storing the zero current sensor offset. Here we switch the FET off and on. We measure the sensor outputs, average the current, and check for overcurrent. Current is the sensor reading divided by the sensitivity, power is the current times voltage, and energy is power accumulated every second. We promise that's all the math for this project. Finally, there are procedures for when it's done and for handling faults like overcurrent. Here are the key components we used in this demo. These are the key features of the analog magnetometer in the demo board. It's non-contact and inherently isolated. It has large output signals, a wide linear range, low hysteresis, and wide bandwidth for fast fault detection. Stay tuned for our next video. We're planning to add a temperature sensor to ensure the hot dog temperature is enough to kill bacteria, because no one wants to get food poisoning from an Arduino project. Click email or call for more information. Our engineers know what current sensors are right for your application. Oh, our lawyers want us to make a few disclaimers. Cooking hot dogs with line voltage is inherently dangerous. Do it at your own risk. Most hot dogs are high in fat and sodium and probably aren't very good for you. Oscar Mayer doesn't really recommend a total energy cooking target. It's geeky humor. The Biot-Savart law is unnecessarily dangerous math. We have a web app, for Pete's sake.